with those, right? Good deal. All right, here we go. What we're going to talk about today is acid nomenclature. Before I forget to tell you, on the very next slide over here is a practice test. If you look at that, it's just you need to cover up the answers, okay? All right, but this is just a little practice test. This has 65 questions on it. Your real test has 50. We will do a practice in class tomorrow also. It'll probably be like 25 or 30, just because that's what we'll have time if we're going to discuss them. But I highly recommend doing this practice test tonight and then doing the practice test in class tomorrow and then reviewing everything tomorrow night. That would be my recommendation. Okay? Test on Thursday. I just noticed on here about there are a couple of these. I noticed like we didn't cover this organic compound right here this year, so you may have to ignore a few things, but I don't know how many of those are on there. Probably a few. Figure it out. No, just alcohols and straight chain hydrocarbons. All right. So acids, here we go. There are two types of acids. All right, binary acids and oxyacids. Now, the first thing we have to be able to do on the test Thursday is we said the first thing is to identify the type of compound that you're looking at. Ionic compounds are easy to identify. They contain what? Oh, wow. Metals, okay, or ammonium, right? If we look at our 5 examples on the board right there, we don't see any metals, correct? So the first one has 2 names in it. They're both nonmetals. That means it's a binary covalent compound. We're going to use that prefix system. The second one only has one name, one word in the name, right? And so we're going to think probably organic. Okay, maybe not though. But if you look at the prefix there, you recognize that ETH to be one of the organic prefixes. So that's an organic compound. PROP is an organic prefix. Carbonate ends in ATE, so that makes us think it's a what? Polyatomic ion. If it ended in ITE, we would think the same thing, unless it was hydroxide or cyanide. Octene, that's a one-word name starting with a common organic prefix, so organic compound. So that's the first thing you got to be able to do because the questions are going to be all jumbled up, okay? So it's not going to be a section of ionic and a section of an organic and section of acid or whatever. It's all going to be mixed and mingled. So you got to identify what you're looking at. Acids will be the easiest to identify because in the name of an acid, you see the word acid. That's if you misidentify an acid, I don't know what to do for you. Okay? But there are 2 types, binary acids. The first one, hydrogen bonded to either a sulfur, one of the 4 halogens, or the cyanide polyatomic ion. That's a binary acid. An oxyacid probably contains what? Based off the name. Oxygen. It's hydrogen bonded to a polyatomic ion that contains oxygen. So, your polyatomic ions. There will be individual standalone polyatomic ions on your quiz, on your test Thursday. There will be ionic compounds that contain polyatomic ions on the test Thursday. There will be acids that contain polyatomic ions on the test Thursday. Probably between a third and a half of the questions on Thursday will contain a polyatomic ion. What does that mean if you don't know your polyatomic ions? You're going to get them all wrong. Okay? You have to know the polyatomic ions. It's just a requirement of the life of chemistry. Okay? All right. Binary acids. So when we recognize that we have acid, then we've got to decide, is it binary or is it oxyacid? Very easy to identify. The name of a binary acid will start with the prefix hydro. Oxyacids do not. So if it starts with hydro, it's a binary acid. Okay. The ending of it has been changed to IC as acid after that. So what we have for our choices are hydrosulfuric, hydrofluoric, hydrosulfuric acid, or hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydrochloric acid, hydrocyanic acid. Okay, so how do we get the formula from this? It's going to start with a hydrogen. It's going to end with whatever the ink substance is. So sulfuric and sulfur, right? So hydrogen and sulfur. How many hydrogens? This is if there's a tricky part to this. This is it. So we're going to put as many hydrogens as there is negative charge. So sulfur would have a -2 charge, correct? Atomic ion. Periodic table, sorry. Right? Follow that. Sulfur would be 2 minus. So this is going to be H2S. No charges. All these acids are neutral. Hydrosulfuric acid. Hydrofluoric acid, what would be the charge of a fluorine? -1, so it's HF. Chloride's -1, so it's just HCl, so it's bromine, so it's iodine. What's cyanide? Cn-1, right? So this would be HCl, hydrocyanic acid. So you see acid at the end of the name, that means it's an acid. That's the simple part. You see hydro at the front of that acid, it means it's binary acid. And all you got to do is put a hydrogen bonded to whatever is in the name. The tricky part is figuring out how many hydrogens there are. It's not too tricky. It's how many it matches the number of charge on the anion part. Okay. Notice again, there are no charges here. Right? Oxy acid. A little bit trickier here with the oxy acids. We've got a little code to keep up with, sort of like a code. First off, they don't have a prefix, so they don't start with hydro. That's how you're going to know they're oxy acids. It ends in acid, but does not start with hydro. That's going to make it an oxy acid. All right, and then looking at the name, whether it ends in IC or OUS, that's going to tell us whether the polyatomic ion ended in ITE or ATE. So the ATEs and the ICs go together. The ITEs and the OUSs go together. Here's what we mean by that. We have nitrous acid, nitric acid, sulfurous acid, and sulfuric acid. Okay. Those are acids, because it says acid. They are oxyacids because they don't start with hydro. The trick here is we've got to figure out which oxygen-containing polyatomic ion this is bonded to. Nitrous means nitrite. So OUS and IT go together. So that means this contains a nitrite anion. Nitric means nitrate. ICs and ATs go together. Can I follow that? All right, so sulfurous will be from what? Sulfite. Sulfuric will be from sulfate. Okay? So what is nitrite? What's the formula for nitrite? Sorry, I got nitrite. NO2, 1 minus, right? Okay. So nitrous acid is HNO2. Nitric acid is HNO3. Because nitrate is NO3. What's sulfide? Sulfur 2 minus, right? So sulfurous acid is H2SO4. Sulfuric acid is H2. Sulfurous acid is H2SO3. Sulfuric is H2SO4. Questions about that? Eights and the X go together, I's and the S's go together. Okay? More examples. Which I'll figure these out. Okay, I'll take just a few minutes and come up with the formulas for those 6 acids. All right, somebody write them up here for us. Put the H in the front. That's a good question. Yeah. So H and then C2H3. That's a good question. Yeah. Putting the H in the front lets people know it's an acid. That H is separate for a reason that we'll learn about like after spring break. It's bonded different. Yeah, and that's what we call the acidic proton. And we'll learn all that about spring break or after program. Everybody good with those? Anybody got any questions about where we come up with those at? Everybody's gonna make 100 Thursday, right? Yep. On phosphoric, phosphate is PO4 3 minus. Yep. So 3 hydrogens to go with a PO4. Yep. Probably. Haven't decided what yet, but I don't know. That easy stuff. No need to be nice now.
It's not in the bag either. I have searched it. Why are you looking at me like that? I wouldn't do something like that. Yeah. You know me. I'm a liar snake. You know me. I would never hurt you like that. Close your eyes and get a measure. See, I look. Close your eyes. Close your eyes. I'm the magician. You can trust. Okay? You
Anybody got any questions before we cut the camera off? We're good.
We're good.
Awesome.
Please let me have the